Welcome to this video. We learned the divisional formula in our previous video. Today in this video, we will learn about the area of triangle with the help of coordinate geometry. Hope you remember that the area of a triangle is determined by the measure of its base and height. We learned in the previous class that if the values of height and base are not known, we can still find the area of a triangle using Heron's formula. But can you guess when this method can be used? Correct. Only when we know the measure of the sides of the triangle. But can you determine the area of a triangle when the coordinates of the three vertices are given? Let's discuss. In a plane with x-axis and y-axis, let DEF be a triangle. The coordinates of the vertex D are x1, y1. The coordinates of E are x2, y2, and the coordinates of F are x3, y3. From the points D, E, and F, if perpendiculars DQ, EP, and FR are drawn respectively to the x-axis, then it looks something like this. If we look at this figure carefully, then we find that the perpendicular EP is parallel to DQ and DQ is parallel to FR. That is, all the three perpendiculars are parallel to each other. And the angles EPR, DQR, and FRX are equal to 90 degrees each. If we talk about DEPQ, then it is a trapezium because we know that if the opposite sides of a quadrilateral are parallel, then it is called a trapezium. Similarly, DQRF and EPRF will also be trapeziums. Can you tell what is the formula of the area of trapezium? Good! The formula to find the area of a trapezium is 1/2, the sum of the parallel sides multiplied by the distance between them. If we add the areas of trapeziums DEPQ and DQRF, we get the area of the whole figure. But we only have to find the area of triangle DEF. Hence, we deduct the area of the trapezium EPRF from the total area to determine the area of the triangle DEF. Can you determine the length of the sides EP, DQ, PQ, FR, QR, and PR with the help of the figure? Absolutely right. Now substitute all these values in the equation. On solving it, we get 1/2 multiplied by x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2, which is the area of a triangle DEF. You might be thinking that the area of a triangle can also be obtained from the Heron's formula, in which the measure of all the sides can be determined by the distance formula, but that is a complex method. So, for solving it easily, we understood this formula in which trapezium was used. Hopefully, through this video, you must have learnt how to find the area of a triangle. In the next video, we will see examples based on this. Welcome to this video. In our previous video, we saw that if the coordinates of a triangle are given, then the measure of its area can be easily determined with the help of this formula. Today in this video, we will see some interesting examples based on this. If the coordinates of a quadrilateral are 1, 1, 7, -3, 12, 2 and 7, 21, then can you find its area? Let's discuss. First, let's represent the coordinates of the quadrilateral with the points P, Q, R and S. Can you guess how to find the area of this quadrilateral? Correct. If we join the point P to the point R, then the quadrilateral gets divided into two triangles, PQR and PSR, with the help of which we can find the area of the quadrilateral. Let's first observe the triangle PQR. Here, let's assume the coordinates of the point P as x1 equals 1, y1 equals 1. The coordinates of the point Q as x2 equals 7, y2 equals -3, and the coordinates of the point R as x3 equals 12, y3 equals 2. Recall and state, how did we find the area of a triangle in such situation? In this formula, we can substitute the values of x1, y1, x2, y2, x3 and y3 and solve. From which we get the area of a triangle PQR as 25 square units. Can you find the area of triangle PSR? Correct. Similarly, when we calculate the area of the triangle PSR, we get it as 107 square units. Since the area of the quadrilateral is equal to the sum of the areas of these two triangles, the area of the quadrilateral is equal to 132 square units. Let's see another example. If the coordinates of triangle ABC are 1, -2, 2, 3 and -4, -3 respectively, then what will be the area of the triangle and its altitude from the point C? Let's discuss this. To start with, let's draw triangle ABC, which looks like this, where we assume the coordinates of the point A of the triangle as x1 equals 1, y1 equals -2, the coordinates of the point B as x2 equals 2, y2 equals 3, and the coordinates of the point C as x3 equals -4, y3 equals -3. With the help of these values, can you find the area of the triangle? Correct. Substituting all these values in the formula of the area of a triangle. On solving, we get the area of triangle ABC as 12 square units, which is represented by equation 1, because we have found the area of this triangle. Now, can you guess how will we find the height, that is, the altitude of this triangle? Very good. We know that the altitude of a triangle makes an angle of 90 degrees with the base. Then the area of the triangle is 1 by 2 multiply base multiply height, which is represented by equation 2. With the help of the distance formula, the value of AB is obtained as square root of 26, which is represented by equation 3. Because we have to find the altitude, we rewrite equation 2 and substitute the values of equations 1 and 3 in it, from which the height of the altitude from the point C is obtained as 24 by square root of 26 units. In this video, we saw examples based on the area of a triangle. In the next video, we will see another interesting example. Welcome to this video. In our previous video, we saw examples based on the area of a triangle. Let's see another interesting example today. Prove that the points 2, -2, -3, 8 and -1, 4 are collinear points. To solve the question, pause the video and then match your answer. Suppose that the points 2, -2, -3, 8 and -1, 4 are vertices of triangle LMN, which are represented as follows. Where the coordinates of the point L are x1 equals 2, y1 equals -2, the coordinates of M are x2 equals -3, y2 equals 8, and the coordinates of N are x3 equals -1, y3 equals 4. Now, with the help of these points, let's find the area of the triangle. Putting all these values in the formula for the area of a triangle and solving, we get the area of triangle LMN as 0. Can area of any triangle be 0? No, the area of any closed figure cannot be 0. And if the area is 0, then we can say that it does not become a figure. So, we can say that our assumption that the given points are the vertices of a triangle is wrong. Hence, the given points 2, -2, -3, 8 and -1, 4 are the points on the same line. That is, they are collinear points. So hopefully, you must have understood how to solve the questions based on the area of the triangle. Teachers can also test the understanding of students in the classroom with the help of some such examples.